Oftentimes, when building integration and generic libraries, we require access to the application's inversion of control, or IOC, container in order to introspect all of the register providers and controllers. For example, if we look at some of the official Nest.js packages, such as Nest.js/GraphQL, we will see that this package traverses an application's module graph and providers by analyzing their metadata to determine which providers contain GraphQL-specific metadata. For instance, the package checks if a class is annotated with the resolver decorator and searches for methods decorated with the resolve field decorator as well. Similarly, if we look at another Nest.js package, the Nest.js scheduler library, we'll notice that this package iterates through all providers as well, checking to see if any of them register scheduler methods, intervals, or cron jobs. So let's learn how we could do similar things ourselves. To help facilitate creating extensible modules and libraries, Nest.js exposes a module known as the Discovery module that we'll showcase in this lesson. Let's recreate our own small scheduler-like library to help us put everything together. Let's start things off by generating a scheduler module using the Nest.js CLI that we'll use as a central point to help us understand everything. Inside of this module, let's generate a single provider and name it Interval Scheduler. We'll use this service to traverse the module's graph and ultimately auto-register any discovered intervals. Let's open up that file and start by annotating it with the injectable decorator. Next, let's make this class implement the onApplication Bootstrap lifecycle hook. Our IDE should prompt us to implement the interface, so let's go ahead and do it. Moving on from here for a moment, let's navigate to our scheduler module file and register the interval scheduler as a provider. Let's also make sure to import the discovery module from Nest.js that we mentioned just a moment ago. Great. Back to our interval scheduler, let's inject a new service called Discovery Service using the standard approach. Next, let's move on to the onApplication Bootstrap method and use the Discovery Service to retrieve a list of all providers registered in our application. Note that if we wanted to retrieve a list of all controllers, we could instead use the getControllers method. If we hover over the providers variable here, we'll see that its type is an array of instance wrapper objects. Instance wrapper is an internal Nest.js wrapper class that represents all controllers, providers, enhancers, and anything that gets registered in Nest's inversion of control container. This class exposes several methods, but in the majority of cases, we won't need a lot of them. Most are simply needed and used by other internal Nest packages and modules. So for demonstration purposes, let's use the forEach method on providers to iterate through this array and then console log each provider's token out. Let's save our changes, open up our terminals, and see what got logged to our console. As we can see, here is an entire list of everything in our application, from modules, configurations, services, and even our interval scheduler itself. Back to our interval scheduler, so far we've learned how to retrieve a list of all provider wrappers. But how can we filter out some of those providers, for example, by checking if they're annotated with a specific decorator, similar to how Nest does itself in certain packages? So before we continue, let's start off by creating a new decorator that we will search for to learn more about how all this functionality works. Inside our scheduler directory, let's create a new folder called decorators, and inside of this folder, let's create a new file and name it intervalHostDecorator.ts. Inside this file, let's declare a new intervalHostKey constant and make it equal to the string of intervalHostKey, which we'll use as our metadata key. Below that constant, let's utilize the setMetadata function exported from Nest.js Common and declare a new intervalHostDecorator as shown here. Let's save our changes, open up our terminals, and generate a new module called cron using the Nest.js CLI. Within that module, let's also generate a cron service. In this newly generated service, let's annotate the class with the intervalHostDecorator that we just created. Great. Now let's save our changes, switch back to our interval scheduler class again, and let's start by injecting the reflector class as the second dependency using the standard approach. With this dependency injected, let's move on to the onApplication Bootstrap method, and inside the providers.forEach callback, let's retrieve the provider's instance from the instance wrapper object. Let's make sure that the instance is not null or undefined, and grab the instance's prototype using the object.getPrototypeOf function. Next up, let's make sure we add a condition checking if both instance or prototype variables are not defined, and if that's the case, let's return to prevent running further code. Doing this is useful to exclude value and factory providers as well. Lastly, let's use the reflector instance and retrieve the instance's metadata like so. So if we get a value here, meaning that there's an interval decorator found, let's log the provider's token down to our console. Let's save our changes, open up our terminals, and as we can see, the only provider that got logged out is our annotated cron service. Great, it worked like a charm. All right, so as we already know how to access providers' host class metadata, how could we analyze the provider's methods? Let's imagine that we'd want our interval scheduler to discover all methods annotated with the interval decorator on its own and register them as intervals automatically for us. Since we don't have that decorator yet, let's go ahead and create that first before we continue further. Let's create another new decorator named interval, just like we did before, and this time with a const interval key. And when we declare our decorator, let's make sure it has a parameter named ms, which is of type number. Let's navigate back to our cron service and declare a new method there named everySecond, annotating it with our new interval decorator, passing in 1000 as an argument. Let's save our changes and head back to the interval scheduler. And let's inject yet another dependency called metadata scanner. Next, let's use this new metadata scanner right below our if condition, calling the getAllMethodNames method, passing the provider's prototype function as an argument. Next, let's iterate through the method keys array and retrieve the interval metadata using the reflector like we have previously. And let's make sure to pass in the method reference as the second argument, which we can grab via instance method key. Like before, let's also make sure that it's not undefined. This helps exclude methods that are not annotated with the interval decorator. And last but not least, now that we've established that we're using the interval decorator on this method and we found a function, let's register the actual interval using the native setInterval function. Let's save our changes, open up our terminals, and take a look at our console. And as we could have expected, we can see the "this will be logged every second" message is being displayed in our console every second. Everything worked perfectly, great. One tiny improvement before we finish though. We always want to make sure we clean up all resources when we terminate our applications. Let's make sure we implement the onApplication shutdown lifecycle hook and close all registered intervals there. So let's start by first implementing the onApplication shutdown interface, and then declare the onApplication shutdown method. Let's leave it empty for now as we don't keep track of registered intervals in our class just yet, but we'll implement that right now. Let's add a new class property called intervals, making it of type nodejs.timerArray. And inside of our forEach callback function, let's make sure we add the interval we create to that array. Lastly, let's head back to our onApplication shutdown method and make sure we clear all the intervals, looping through everything in the array and calling the clearInterval method on each iteration. So we've covered a lot in this lesson. And although we created just a simple utility decorator for easily turning methods into intervals, hopefully you can see the power of what we've accomplished and how you could add much more intensive or useful functionality in your future applications utilizing the same strategies we put to use here.